Okay, so the question is, there's a system which is released from system rest and with the cable tau for the friction coefficient mu s mu k are given, and we need to find the acceleration for each body and tension in the cable and assume that mass and friction of the body. Okay. So here when the system is at rest, so here we'll talk about the forces acting on 20 kg and that's A kg, and there's a in this question the mass of A kg is given. Okay, so that is given, which is not visible here because of the diagram, but that is given. Okay, so here if we see the tension, so let's assume the tension in the string is T. So here it is T, so then it is T, this is T, then it will be 2T. Now the system is at rest, which means this 20 kg is at rest, so 2T on 20 kg will be equal to 20 into G, right? That is that gravity acting. So from here the T equal to 10G. The tension is in the string is 10G. Now base with this value, we'll try to find out whether this A block is moving or not. There is a friction, and we'll check whether the external force is less than or greater than limited friction. So for that we'll try to find the external force. So this is 60G sine 30, which is nothing but 30G. Okay, so the net external force is 30G minus T, which is 10G. So it is coming as 20G. So now it is 200 Newton if we take G value is 10. So I take G value is 10. And the limited friction is mu s, which is 1 by 4 into 60G into root 3 by 2. So if we solve this one, it will come 127.5 Newton. Okay, so we can solve it. Now it is clearly visible that F external is greater than limited frictions, and because of this the block A moves. Now we'll focus on the acceleration. So A is moving downward, so it has acceleration that's A. Then because of the string constraint, this B 20 kg block will have acceleration A by 2 in upward direction. Okay, now the thing is, we'll write the equation basically. For A block, if you write the equation, so the force acting on A block, which is 30G in downward direction, there is a tension T, and because now the system is moving, so the tension will not be 10G, it should be different. So we will try to find out that. So 30G minus T, and there is a friction acting in opposite direction, so which is kind of friction is acting, which is 0.2 into 60G in cos 30, which is equal to the mass 60 into A. And now if we write the equation for B block, now B block is moving upward, and so equation on this one is 2T minus 20G is equal to 20 into A by 2, which is 10A. Okay, now we'll remove the tension. So for that we multiply this equation with 2. So when we multiply this equation with 2 and we'll add these two equations, so we'll get 60G minus 20G, so we'll get 40G. Here we'll get this 2 will be cancelled, so here we are getting 120 root 3 is equal to, and it will be 120 plus 10, 130. Okay, so here now we'll solve this value. 40G, which is 400 minus 120 into, like, we put the value 1.7. So 1.7 will come as 204 is equal to 138. So it is coming as 196 equal to 130A. So I'm writing here A is equal to 196 divided by 130. So it is coming as 1.5 almost meter per second. So this is the acceleration of the system of A block, and if you write the acceleration of B block, so it will be A by 2. So 1.5 divided by 2. So acceleration of, so I'll write here, acceleration of A is 1.5 meter per second square. Acceleration of B is A by 2, which is 0.75 meter per second square. And the tension in the string, so for that we'll use this equation. So the equation C is that 2T equal to 20G plus 10. A is 1.5, so it is like 15. So 20G plus 15, right? So 200 plus 15 basically, so 215. So tension is coming as 215 divided by 2, which is 107.5 Newton. So that's the answers. Okay, thank you.